Alright guys, our last thing that we're going to talk about polynomials is how to multiply them, okay? Multiplying polynomials is a pretty simple thing. The main property we use when we're multiplying polynomials is called the distributive property, okay? When we're multiplying any number by something that's in parentheses, that number needs to be multiplied by everything that's in there, and that's what the distributive property says. Okay, now when you're multiplying polynomials, typically you're multiplying, a monomial by a binomial, or a binomial by a binomial, or we could have a binomial by a trinomial. I have all those examples here. So this is a monomial by a binomial. This is a monomial by a trinomial. This is a binomial by a binomial. All three of those. And then this is a binomial by a trinomial, okay? You could go on and do, long polynomials by other long polynomials. But the main key is that when you're multiplying two things together, everything needs to be, this needs to be multiplied by everything in the parentheses, okay? So, when we're multiplying here, it goes back to our monomials lesson, all right? You're going to have to take this monomial and multiply it by this monomial, which is just like multiplying monomials. It's all just using those rules when adding exponents, okay? And then you're going to have to take this and multiply it by this, okay? So what we say, I like to draw my arrows, all right? This whole entire monomial right here out front is getting multiplied by both of these things, these two individual ones. So negative 5g squared h needs to be multiplied by 3g squared h squared plus, and also needs to be multiplied by 5, okay? So I draw my arrows and show, okay, it needs to be multiplied by that, and it needs to be multiplied by that, okay, to show I need to be doing two steps here, all right? So that means my negative 5g squared h is going to have to be written twice, okay? Okay, I suggest that you do your additive inverses first, always to work with addition signs. Since this is an addition sign here, these two things are going to be added, and we're going to need to multiply this by 3g squared h, and we're going to multiply this by 5. And since this 2g squared h to the third power is not inside the parentheses, it does not need to be multiplied by this monomial out here, because this is simply saying I have something and I need to multiply it by two other things that are in here, and then I need to add this thing at the end, okay? So this right here only needs to be multiplied by those two things, and then we add that at the end, okay? It's very important to include that though, and don't drop it off, okay? So you then are going to multiply your monomials together, then treat it like adding and subtracting polynomials, and combine like terms and write it in standard form, okay? So if you remember when we were multiplying monomials, we would multiply the coefficients, okay? So negative 5 and a positive 3 gives me negative 15, okay? G squared and G squared gives me g to the fourth, because I add the exponent. And if I want to put my h to the first power on both of those, h1 and h1 give me h squared. Alright? Plus, negative 5 times 5 gives me a negative 25. And then my g squared, there's no other g's that multiply with it, and there's no other h's, so I'm just going to keep that the same. And then there's nothing multiplying this one, so 2g squared h to the third power. Now, I need to decide whether this is written in standard form or not, okay? This has a degree of 6, this has a degree of 3, and this has a degree of 5, okay? So this one needs to be written before this one, so I'm going to rewrite it again in standard form. Negative 15 g to the fourth h squared, that goes first because it has a degree of 6. Then this one needs to go second, plus 2g squared h to the third power, and then plus negative 25 g squared h, because it has the least amount. It has the least degree. Okay, so It's essentially the same. It's a combination of all three things we've learned, okay? Multiplying monomials, adding polynomials, and then writing them in standard form, okay? All right, so let's move on to the next example. We have negative 2/3 m squared times all of this in the parentheses, negative 9m squared plus 3m plus 6, okay? This is a different thing because we have a fraction, but we treat it still as a coefficient. So my negative 2/3 m needs to be multiplied by this one, and this one. All three of those it needs to be multiplied by, okay? So I'm going to rewrite it 3 times. Negative 2/3 m squared, negative 2/3 m squared, negative 2/3 m squared. Okay, I need to multiply by negative 9m squared plus times 3m plus and times it by 6. Okay. Alright, so when we're looking at it with a fraction, all it is like a normal number, okay? You can use your calculator if you need to. All I'm going to do is multiply negative 2 times negative 9 to get 18, and then divide by 3 to get 6. So 6 is our new coefficient. M squared and n squared multiplied together gives me m to the 4th, because I add the exponents, okay? Let's look at our coefficients. Negative 2 times positive 3 gives me negative 6 divided by 3 is a negative 2. Alright, and I have m squared and m to the first power, so that gives me m to the third power here. Then we have coefficients. Negative 2 times 6 is negative 12 divided by 3 is negative 4, so plus a negative 4. And there's only one m squared here. Alright, and then I look and I say, is this in standard form? Well, we got 4, 3, 2. Yes, it's in standard form, so that answer is complete. Okay, so those are our first 2 examples, multiplying a monomial by a binomial and a monomial times a trinomial. Now we have 2 binomials being multiplied together. There's multiple ways to look at this, and I know some of y'all might know a box method or something like that. I like to stick with my traditional distributive property, okay? I'm saying these 2 things are being multiplied by each other, okay? So everything in this needs to be multiplied by everything in this, okay? So you want to use the distributive property. 3x needs to be multiplied by 2x, and 3x need to be multiplied by 3, okay? Then 5 needs to also multiply by everything. 5 needs to multiply by 2x, and 5 needs to multiply by 3. Okay, so you got lots written out here. Okay, so I take the first one and I say, all right, 3x, oops, black's running out. We're going to multiply it by something twice. Okay, we're going to multiply it by 2x here plus 2x here. Oh, sorry, plus 3 here. Sorry. Okay. Alright, so 3x is multiplied by 2x, and 3x is multiplied by 3. And then 5 needs to be multiplied by 2x. And it needs to be multiplied by 3. Mixing up my colors today. Okay, so if you notice, every single thing is multiplied by each other, and that's very, very important here. It's not just one thing being distributed. Both things here is distributed to both things there. Okay, now we simply look at each individual of these monomials and simplify the monomials by themselves, and then we're going to look and simplify the polynomial. Okay, so 3 times 2 is 6. Alrighty. I've been using different colors, I know. 3 times 2 is 6, and x to the first power and x to the first power gives me x to the second power. 3 times 3 is 9. We have only one x here. 5 times 2 is 10. We have only one x there. And 15 times 3, or 5 times 3 is 15. Okay, now I want to look and see if this is written in standard form. Okay, I have x squared, and then I notice that I have two like terms here. We have 9x and 10x that need to be combined before this is in standard form. Okay, there's no more x squared, so we're going to write 6x squared, 9x and 10x give me 19x, plus my constant, which is 15. And that is what a binomial times a binomial looks like. All right, simplified. Okay, I've got two more examples of binomials down here. Stop and pause and try to do them on your own, and then check your work. Okay? All right. Distributive property. Distributive property. Okay, I got 5a times 4a plus 5a times 7 plus 6 times 4a plus 6 times 7. Okay, 5a times 4a gives me 20a squared. 5a times 7 gives me 35a. 6 times 4 gives me 24a. And 6 times 7 gives me 42. Alrighty. So now we look and we say, is this in standard form? No, it's not in standard form. I need to combine my two a's here. So 20a squared. 35 plus 24 gives me 59a. And 42 is my constant. So that is my simplified monomial. Okay? Alrighty. Last one. This one has a negative in it. Alright, so we need to go ahead and do our additive inverse here. We have a negative 3 instead of minus. Alright? 4a times a, 4a times 4, and negative 3 times a, and negative 3 times 4. Alright? 4a times a plus 4a times 4 plus negative 3 times a plus negative 3 times 4. So we're going to have 4a squared plus 16a plus negative 3a plus negative 12. 16a and negative 3a combine to be 4a squared plus 13a plus negative 12. And that is my final simplified polynomial. Okay? Last example I have up here is a binomial times a trinomial. Okay? We're going to be using that same steps we have been using. Everything in here needs to be multiplied by everything in here. Okay? So it's just a little bit larger and it takes a little bit more space. Okay? So 2m needs to be multiplied by 4m. 2m by negative 8a. Oh, we got a negative. So we're going to do the additive inverse, okay? And 2m also needs to be multiplied by 2. 3 by 4m, 3 by negative 8a, and 3 by 2. Okay, so you're probably going to need, a lot of room. Notice, guys, I'm taking up a lot of space. I'm writing step by step by step what my thinking is. You need to be doing this step by step by step to be successful, okay? All right, so we have 2m times 4m plus 2m times negative 8a plus 2m times 2. Alright, I'm going to have to go off the screen. So I'm going to roll down here. Plus 3 times 4m plus 3 times negative 8a plus 3 times 2. Alright, so let's go ahead and simplify our monomials. 4 times 2 is 8. M times m is m squared. 2 times negative 8 is negative 16. M times a is just ma. Alright. 2 times 2 is 4. Only have one m. 3 times 4 is 12 m. Plus 3 times negative 8 is negative 24a. Plus 3 times 2 is 6. Okay, we need to look and see if we have any like terms. No m or m squareds, no more ma's. We got 2 m's by themselves, no a's and no constants. So all we simply have to do is combine those 2 m's to 4m and 12m gives me 16m plus negative 24a plus 6, okay? That is probably as complicated as it gets, unless you had a trinomial by a trinomial and you have to multiply it all multiple times. All right, thank you.